So in the today's lecture, we are going to start the next topic is force on side wall of the vessels, right? For example, suppose this is the container, right? And in this container, the liquid is filled. The density of the liquid is rho, and this is the side wall. You may assume the height of the container is h. This is the side A, and this side is B. So if you consider this the P naught, the atmospheric pressure, right, like this. So if you consider this the atmospheric pressure, so because of this pressure, as we are moving down, the pressure will increase, right? So you have to find the expression for the force acting on this wall, right? Listen one thing. From this is open to air, you can assume this is open to air, therefore this is the atmospheric pressure at distance x. Can you tell me what is the pressure? Suppose this is the height h, total height is h. What is the pressure at this point? At this point, the pressure will be P naught plus h, that is x rho g. This is the pressure at this point. If you assume a small strip of width dx, are you getting or not? So from inside, this is the 3D view, right? If you take the side view at distance x, if you consider the small strip of dx, right, this is the width dx. So from inside, the water is filled like this, right? Water is filled, and therefore the pressure is acting. What is the pressure at this point? Say P naught plus x rho g. P naught is due to the atmosphere plus x rho g due to this column, and outside also the pressure is acting because other side is also the atmospheric pressure. So therefore the F1 and F2 are acting, and F1 will be greater than F2. So what is the net force? What is the net force? Net elemental force on this strip. On this strip, the net elemental force will be acting. The pressure is equal to what? Say force upon area. So force F1 minus F2. So what is the F1? Say pressure, this pressure P naught plus x rho g into area, right? The area is the area of this strip. If the width is dx and the length is what? Say BA. So the area you may write the length into width. B into dx is the area, right? Minus, what is the F2? F2 is the pressure exerted by the outside pressure, right? This is the F2. So this pressure is P naught into dA again. Are you getting or not? So this P naught and dA will cancel out. So x rho g into dA. This is the elemental force. Elemental force on this elemental ring, x rho g into dA. What is the dA? Say B into dx. So this is the dF. Is it clear or not? So how to find the net force? The net force would be found by integration of dF, and this is equal to x rho g dx. Is it clear or not? And you will integrate from the strip start from here, then this is the another strip, right, like this. This is the another strip, and the strip goes from x is equal to 0 to x is equal to h, right? So you will integrate this. Rho g is the common quantity. X integration is x square by 2 from 0 to h. Now you will put the limit rho g, the upper limit h square by 2 minus 0. What is the net force on this side wall? Is equal to rho g, wait for 1 minute, area, this is the B is also left, rho g B into dx. This is the B, this is B, right, and this is B into h square by 2. Is it clear or not? Rho B h square by 2, right? So this is the net force. Are you getting? Although this is the derivation, but I am telling you the shortcut. What is the shortcut? Listen one thing. If this is the container and you are looking from its side, right? So ignore the atmospheric pressure, because the atmospheric pressure from both sides will cancel each other. You tell me the gauge pressure at this point is what? Say 0, right? As you are moving down, what is the pressure is increasing? X, H, rho, G is the pressure at this point. Is it clear or not? So the pressure at this point is 0, and when you are moving down, so the pressure is increasing and it become H rho G. Is it clear or not? So this is the first point, this is the second point, and the depth of the column, water column, is H. So what is the average pressure? Is equal to P1 plus P2 by 2, that is H rho G by 2 is equal to H rho G by 2. First you have to find the average pressure. Then what is the area of this side wall? What is the area of this side wall? The area is B into H. This is the B, this is the H. So the average force will be acting, average pressure multiplied by area. So the average pressure is H rho G into A by 2. Area is B into H, right? So B H rho G upon 2. This is the B square. Sorry, this is B into H into B. This is the B into rho H G square. So in this way you can write the force also. Okay, copy this. So this is the total force you can find on the side of the wall. But if sometime the two liquids are filled of the different density, for example, if we have, this is the vessel and up to height h1, right, the density is rho 1 over here, the height is h1, suppose the another liquid is the rho 2, the height is h2, right? Suppose this is the width is B, and this side of the vessel you can assume this is to be A, right? So this is the one side here and this is the another side here. The absolute pressure to find the force on this wall F1 and to find the force on this wall F2. Are you getting or not? So the average force is equal to pressure into area. We know the area. This is the H1 into A. This is the H2 into A. But what is the average pressure you will assume? Ignore the atmospheric pressure because the atmospheric pressure will cancel out. So here the pressure is 0. What is the pressure at this depth? This is H1, right? I am assuming this is the P1. The value of P1 is what? Say H1 rho G, right? And when you move down, what is the pressure at this point P2? Say H1 plus H2 into rho G. Is it clear or not? So what is the average pressure at this point? The average pressure multiplied by area A1, right? This is the F1 and this is the average pressure 2 into area 2. The force will be like this. So how to find the average pressure? The average pressure 1 for this wall will be 0 plus P1 by 2. All right. And what is the average pressure for this wall, for this side? P1 plus P2 by 2. Although this can be calculated in a lengthy way using the integration, but this is the shortcut and it will work. Right. So P1 is what? Say H1 rho G by 2. And what is the P average at this point? P1 H1 rho G. And what is the P2? It is H1 plus H2 rho G by 2. Right. And when you will simplify this, you will get 2H1 plus H2 rho G by 2. Is it clear or not? Fine. Now, if you want to write the force expression, the force F1 and F2 can be written easily. What is that? F1 is equal to P average 1 into A1. What is the P average? 1. It is H1 rho G by 2. What is the area? Area is H1 into B, H1 into A. H1 into A. I assume this side to be A, right? And what is the force F2? Average pressure 2 into area 2. What is the average pressure we have found? Say 2H1 plus H2 rho g by 2 into area. What is the area of this side? This is the H2 into A. H2 into A. I think you are getting the concept, right? Copy this. Oh, make a mistake. Right, you are correct. I make a mistake. So this is the row 1, right? Wait for 1 minute. This is the row 1, density row 1, right? And this is the density row 1. It is row 1, it is row 2. So make this as it is. Is it clear or not? Because the density are different. So this is rho 1. The average pressure 2 will be equal to what? Say H1 rho 1g plus H1 plus H2 into rho 2g divided by 2 into area. Area is H2 into A. Fine. Now it is correct. Copy. Please make it correct. This is the rho 2 also, right?
Sir, I have a doubt.
Yes, please.
Sir, how is P2 H1 plus H2 rho 2G? Because in H1 there's only rho 1.
This is also mistake. Actually, yes. P2, what is the P2? Oh, let me do it once again because there is again mistake, right? Wait for 1 minute. Okay, so listen one thing. Is this the density rho 1 and this the density rho 2? So I will write first the pressure P1 at this point, right? And what is the pressure P1 at this point? Excess pressure H1 rho 1 G. And the P2 at this point, the pressure is what? Say H1 rho 1 G plus H2 rho 2 G. This is the pressure. Now it is correct, right? And for this average pressure, P average 1 is equal to what? 0 plus P1 by 2. And what is the P1? Say H1 rho 1 G by 2. And the average pressure 2, right, at this point is P1 plus P2. P1 plus P2 by 2. Right, and this is the P1 H1 rho 1 G plus what is the P2? H1 rho 1 G plus H2 rho 2 G divided by 2. Now it will be correct. It will be 2H1 rho 1 plus H2 rho 2 divided by 2 into G. This is the average pressure, right? So the force F1 can be written as, this is the average pressure H1 rho 1 G by 2 into area A into H1. F2 is equal to what? This is the pressure 2H1 rho 1 plus H2 rho 2 divided by 2 into G into what is its area? HA into H2. Now you can copy. It is correct, right? So if the two or more liquids are filled in the vessel, the net force you can find, right? So now in the next topic, we can also find the torque, right? The torque, tau. How to find? Suppose this is the liquid filled in a tank or the vessel, right? And this is the side wall, right? This is the side wall. All right. Suppose this is the side wall. So this is the point A, suppose this is the point B. So if you consider a distance x and the width of the strip is supposed to be dx, right? So the force will be acting over here. What is the df force? The df force is equal to pressure at this point into dx. Although at this point is pressure is equal to P naught plus x rho g, right? Outside pressure is P naught. So the pressure, the net pressure will be equal to x rho g into dx. I think you are getting in the, and this is the area, this is the dA. All right. And what is the dA? Suppose this is the B and this is the A, right? This width is B into dx, B into dx. So this is the force, elemental force. dF is equal to what? B rho g into x into B rho g into x into dx. All right. So about this point, if they want to find the torque of this net force, so how to find the d tau? D tau will be elemental torque about A. D tau is equal to df into perpendicular distance. And what is this perpendicular distance? I think it is x. So what is the elemental force? B rho g x into dx multiply by x. Is it clear or not? And this is the d tau. So to find the net torque, what you have to do? You have to integrate B rho g x into x. It becomes x square into dx, and x varies from 0 to, suppose this is the height, this is the depth h from 0 to h. So B rho g, right, and the torque is x cube upon 3 from 0 to h. So the net torque about this is what? Say B rho g x cube upon 3 minus 0. When you will put upper limit minus lower limit, so the net torque is B rho g h cube upon 3 about point A. Is it clear or not? Copy this. So now this is the net torque about this point of the force. Because the force is varying, the depth is varying, right? Therefore the torque will be calculated using the integration. All right. Now in the one more questions which can be asked, which is the point of application, right? Point of application of force. So where the effective force is acting on the side wall. So how to find? Suppose this is the container, right? And the net torque about this we have found. So we have to find at this distance, at the from the point, right, top point A at distance x, where we can assume the net force is acting at that point, so that it will produce the same torque as it is produced by this depth of the water column or the liquid column in the container. All right. So can you tell me, if this is the side A and this is the side B, what is the net force? What is the average? What is the net force? The net force is, average force is what? Say h rho g by 0 into 2. And what is the area? This is the h and this is the B. What is this area? Force is equal to average pressure and the area is h into B. Is it clear or not? So what is the average pressure? The total pressure h square rho g b by 2. Is it clear or not? So if this is the x and this is the point of application P where the net average force can assume to be acting. So what is the torque? The torque about A. Torque about A. What will you write? The force, average force, multiplied by distance of the point where the net average force is acting. This is the point of application, you can assume this is the x. And what is the net torque you have calculated by integration? This is B rho g h cube upon 3 is equal to what is the net force? Say h square rho g b by 2 into x. Is it clear or not? So when you will calculate, this is h upon 3 is equal to 1 by rho, right? Because rho bg cancel out. So this is 2h by 3. So this is the application of the point where the force can be assumed at that point so that it will produce the net torque as it is produced by this liquid column. Is it clear or not? Copy this. So in this question, what we have the water up to height h, right? This is the water and the density of the water is assumed to be rho, and the liquid, other liquid of the density, the 2 rho is filled up to height h, right? Suppose this is the h1, the 5 meter is given, right? And the h2, again the 5 meter, the liquid is filled. This is the point A, this is the point B, and this is the point C, right? This is the square wall, all right? And the length of the side is 10 meter. This is the 5 meter and this is the 5 meter. So in the part A, and atmospheric pressure assumed to be 0. In the part A, the pressure at A, B and C, they are asking. So what is the pressure at A? Because the height is what? Say 0. So the pressure at point A will be equal to what? Say 0. What about B? The pressure at B is equal to what? Say H1 rho G. What is the H1? H1 is the 5 meter. Density of the water is 10 to the power 3 kg. Right. And G value is 10. So 50 into 10 to the power 3 Pascal. Right. Or Newton per meter square. This is the VB. And what about at C? The particle at C is what? P0 plus H1 rho G plus the density is rho 2, H2 2 rho G. Is it clear or not? So how to find the pressure? H1 rho G. When you will calculate the H1 rho G, it is 15 to 10 raised to 3. This is the H2 again, the 5 into 2 into density into 10. Is it clear or not? So this is 10, 5 to the 10 and 150. 150 into 10 to the 3 Pascal. So this is the pressure at point C. Is it clear or not? This is the pressure at C. Fine. So this is the first part. Now what they are asking? In the second part, they are asking the force in the part AB. This is the part AB. So the force F1. This is the part BC. The force F2 they are asking. So I told you in the concept, the force is nothing but the average force multiplied by area. This length is what? Say 10 and this is the 5. So what is the area? 10 into 5. Right. So and how to find the average pressure? PA plus PB. PA plus PB by 2. The average pressure is PA plus PB by 2. And what is the area? 5 into 10 meter. And this is the 50. Is it clear or not? So the P is 0. I am writing this side. So 0 plus PV into 10 to the 3 by 2 into what is the area? Say 50. You will calculate and you can get the answer. What is that? This is 25. 25 पंजे 125, right? And into 10 की power 4. So this is 125 into 10 to the power 4 Newton. In the same way, the average force on this side will be equal to the average pressure multiplied by area. The average pressure is PB plus PC by 2 into area. What is the area? Again 5 into 10, this is the 50. The PB plus PC. This is the PB and this is the PC. So 50 into 10 ki power 3 plus 150 into 10 ki power 3 divided by 2 into 50. So you will get 200 into 10 ki power 3 into 25. So this is 50 into 10 ki power 5 Newton, or you may write 500 into 10 ki power 4 Newton. Is it clear? So this is the value of F2. This is the value of F1. So if somebody asks what is the net force, right, in the second force, the net force on this wall of the tank is F1 plus F2. F1 plus F2 is equal to 125 into 10 ki power 4 plus 500 into 10 ki power 4. So this is 625 into 10 ki power 4 is equal to 6.25 into 10 ki power 6 Newton is the correct answer, right? So this is the first part and this is the net force on this wall. Copy this. So now we are going to find the net torque or the point of application. The third part is that total force and the point of application. So the total force we have found. What is the total force? 6.25 into 10 ki power 6 Newton is the total force. And the point of application mean where the torque, where the net force assumed to be acting at that point, so that the torque about A, if you consider, right, is same as that of produced by this force. Is it clear or not? So this is the force. Let's X is what? Point of application. Find point of application. X is the distance of the point of. This is the distance of point of application from end A. From end A we are. So therefore, what will be the net torque? Net torque will be equal to total force multiplied by X. We know the force, total average force. We have to find this. So therefore, we have to find the net torque. So how to find the net torque? Listen, if you consider this the part, this is the force F1 is acting, and the torque about this of this force you have to find. The torque about this you have to also find. So to find the torque, right, you have to integrate. First, if you consider this the height h, the net torque, right, torque of F1, force F1 about A. What is the torque tau 1? The torque tau 1 we have calculated, right? In the previous questions, I have calculated the torque, and this is 1 upon 3 rho g L into h cube. Is it clear or not? So this torque we can write directly with respect to A. The torque on this face I can write. The density is 3 G 10 and this is the 5 cube. 5 पंजे 25 पंजे 125, 125 by 3 into 10 की power 5 Newton meter is the net torque, right? The thing is that we have to calculate the torque of F2, right, about A. To find the torque about A on this face, I will assume a distance x, right? The width of this is supposed to dx. So what is the df force acting over here? What is the pressure at this point? What is the pressure? Say the pressure at this point I will write, this is the h rho g, are you getting, plus the pressure of this water column height. The density is 2 rho, and what is this depth? If this is total distance x and this is h, h1 is 5, so x minus 5 I will write. So the pressure due to this column is S, right, S rho into G, S rho G. Are you getting? So, and H over here is what? Can you tell? H over here is what? H1, right? And this is 5 rho G plus x minus 5, 2 rho G If you calculate, the rho g is common. Fine. 5 plus 2x minus 10. So you will write 2x minus 5 into rho into g. So this is the pressure at this point. If you are able to find the pressure, so df force you can write. So I am going to find the torque due to the force F2. So first I will write this df force is equal to pressure into the area. What is the pressure? This is the pressure we have found. 2x minus 5 rho g. And what is the area? Dx into, this is 10. Dx into L. And what is the value of L? Say 10. Is it clear or not? So if you calculate, this is the df, 2x minus 5, 10 to the 3 into 10 into 10 into dx. So df is 2x minus 5 into 10 to the power 5, right? The df. So what is the d tau? I'm finding the torque due to the force F2. D tau is equal to what? df into x, about a. I'm writing about a. So because this is the perpendicular distance in the df acting. So net torque tau is equal to df into x. So what is the df value? 2x minus 5 into 10 to the power 5 into dx into x. And what is the value of x? The value of x will lie from, right, the strip start on this face. Start from here. This is the another strip. This is the another strip. And this is the final strip. So the value of x varies from 5 to x is equal to 10. Right. So this is 0 to, 5 to 10. Is it clear or not? So if 10 raised to 5 is out of integration, it become 2x square minus 5x into dx. Right. 5 to 10. This is the 10 raised to 5, 2x cube upon 3 minus 5x square by 2 from 5 to 10. Is it clear? So now if you put the upper limit and lower limit value, and you can get the answer. You can get the tau 2, right? Copy this. So now you can put the value, right? What is the tau 2? The tau 2 I am writing over here. This is the 10 raised to 5. Put the upper limit and then lower limit. This is the 2 into 10 cube upon 3 minus 5 upon 2 into 10 square minus 2 by 3 into 5 cube minus 5 by 2 into 5 square. Is it clear or not? So this is 10 cube of 5, 2000 upon 3 minus 250 माइनस 5 25 5 125 दूनी 250 बटे 3 5 25 125 बटे 2. All right, like this. So I'm deleting all this. So this is 10 raised to the power 5, right? Make this calculation correct to 10 to the 3 minus 250 upon 3, right? Minus, and this is the minus, plus 125 by 2 minus 250. All right, this is 750 upon 3 minus 125. Oh, this is what? 500. 375 by 2 it will be. 10 to the 5, and it is 3 पंजे 15 और 3 अट्ठे 24, 3.3 minus 3 अट्ठे 16, 7.5. All right, so this is how much? This is 583.3, 187.5, 0.80, 8 दूनी 16 और 1 17 से लग गया 1 और 6 और 1 7, राइट? 13 में से 5 के बचे 8, 12 में 7 के बचे 5, 9, 4 में से 1 गया 395, 395.8 approximately. This is the tau 2. So what is the net torque? Is tau 1 plus tau 2. The tau 1 is 41.7 into 10 to the power 5, right? 10 to the power 5. It is 41.7 into 10 to the power 5. Make it correct. Plus tau 2. This is the 395.8 into 10 to the power 5. So when you will add 41.7 15, 7, 13, 40. So this is 437.5 Newton meter into 10 raised to power 5 Newton meter, right? Now to find the value of x, which is the point of application, the net torque is equal to net force multiplied by the perpendicular distance x. Net torque divided by net force. The net torque is 437.5 10 to the power 5. The net force we have found the 6.25 into 10 to the power 6, right? So approximately 7 meter you will get the answer when you will simplify, right? Copy this. So the question is, the height of a mercury barometer is 75 centimeter sea level and 50 centimeter at the top of the hill. The ratio of density of mercury to the air 10 to the power 4. The height of the hill you have to find. So in this question, suppose this is the hill, right? Here the barometer is placed, fine, and in this case the height of the barometer is what? So it is 75 centimeter and this is the sea level, right? And what about this? When the barometer is the top of the hill, right? And when the barometer is placed, the height of this barometer is what? A little less, and it is what? It is 50 centimeter. Is it clear or not? So if you consider this point and this point, the pressure at this point is P1 and P2, and here the air column is there. In the question also, the density ratio of the mercury to the air, it is given as 10 to the power 4. So density of air is density of mercury divided by 10 to the power 4. If the pressure is P2 over here, I am assuming this is the P2 and this is the P1, right? The P1 and P2. As we go down, the pressure will increase or decrease? Definitely, the pressure will increase. The P2 is greater than P1 and P2 minus P1 is equal to what? H rho G. This is what? This is the air column. So what density will be over here? The density of air is equal to, it will come in this expression. Is it clear or not? What is the H? H is the height of the top of the hill to the sea level. Is it clear or not? This height only we have to find. At this point, what is the pressure? Pressure, if we measure by the barometer, right? So it comes to be 75 centimeter of mercury column. So here H2 rho mercury into G minus the, I am assuming this is the H2, the barometer height. Here the barometer height is what? Say 50. H1 rho mercury into G, H into rho air into G. Is it clear? I think G will cancel out. And what is the rho air? The rho mercury divided by 10 to the power 4. This height I will put in centimeter. 75 rho mercury minus, and what is this height? This is the 50 rho mercury. It is in centimeter. So here also this height of the air column, right, will also come in the centimeter. Rho mercury will cancel out. 75 minus 25 H upon 10 to the power 4. So what is the value of H you are getting? The H is 25 into 10 to the power 4 centimeter. So in meter, it is in meter. So in kilometer, 2.5 kilometer. So the height of the top of the hill from the sea level comes to be 2.5 kilometer. So the B option is the correct option, right? Copy this. So in this example, the barometer kept in a stationary elevator reads 76 centimeter. If elevator start oscillating up, the reading will be less or more, you have to tell. Suppose this is the lift and this is the barometer. It is placed inside the lift. It is at rest. So when it is at rest, the pressure at this point will be equal to the pressure of the atmosphere, and this height comes to be 76 centimeter initially. Is it clear or not? So what will, in terms of height of the barometer of mercury column, the H rho, I am writing initially it is H1 rho into G. Is it clear or not? Now, due to some reason, suppose this the elevator start moving up. Is it clear or not? It start moving up, start accelerating up, right? If the elevator start accelerating up, the reading will be what? Fine. So if this is the barometer, if you are standing on this and you are observing the column of the mercury in the barometer, suppose this is to be the H2. At this point, the pressure will be what? Say the atmospheric pressure will be the same. It does not change due to the acceleration of the lift, right? The pressure of the air will be the pressure same. Whether the lift is going down or up, it does not matter. So the P naught, what is the pressure P naught? Is equal to H2 rho G plus A. Why G plus A? You tell. Because with respect to this, the acceleration due to gravity become G plus A, but the pressure is what? Same. So H1 rho G is equal to H2 into H2 rho G plus A. Rho will cancel out, so H2 is equal to what? H1 up into G upon G plus A. You tell me. The height of the barometer when it is moving up will increase or decrease? G upon G plus A. It will decrease. Although it is asked whether it will increase or decrease, so it will be less than 76, right? But if the acceleration value is given in the question, if you put the value in this expression, the new level of mercury height, mercury column in the barometer, you can find using this formula. Is it clear or not? Copy this. So in the next example, barometer tube reads 76 centimeter of mercury. If tube is gradually inclined at angle 60 degree with vertical, you have to remember keeping the open and immerse, keeping the open and immerse in the mercury, the length of the mercury column. What is the question? It is a very general question, right? Asked many times. If this is the mercury column, right, when it is vertically, and the mercury column is equal to 76 centimeters, suppose this is the H. Now, if this mercury is the barometer tube, right, is inclined gradually, are you getting or not? Like this. So the mercury level will in the same way. Suppose this is the X, and from the vertically the angle is given vertically, it is very important, and this is H. So what is the, this is 60 degree, this is 30 degree. Sine 30 is what? H upon X. This is equal to 1 by 2. So what is the X? Is equal to 2H. The X is equal to what? 2 into H. H is what? 76. So 152 centimeter X. Are you getting or not? So what is the length of the mercury column in this tube? Is 152 centimeter. The option A is the correct option, right? Copy this. So now in the next example, cubical container is there, right? Suppose this is the container. Fine. The container point is what? A, B, C, D, E, F, G, H. All right. And it is accelerated. Suppose this is the x-axis, y-axis and z-axis. Are you getting or not? The acceleration is a naught, I minus j plus k cap. Is it fine? So if the acceleration is a naught I cap, this is the x direction. So if you consider a molecule and you are sitting over here, the force, pseudo force will be in this direction because of this a naught I cap. This is minus j cap. This is in the direction j, right? So the force will be acting in this direction. The atmospheric pressure assumed to be 0, neglecting non-viscous force. The pressure will gravity free space. It means the atmospheric pressure is 0. This is the pressure. What does it mean? Due to this reason, the pressure is increasing in this way, right? In this way, the pressure is it is moving in. Wait for 1 minute. The minus a naught j cap. The acceleration is downward direction. So what is the pseudo force direction? Right, the pseudo force in this way. So the pressure is increasing in this way. If you consider this the wall, so the pressure of this wall is more than this wall. The same way, if the pseudo force is acting in this direction, why? Because the acceleration is in this direction, I cap. Fine. If you consider the j cap, k cap, a naught, k cap mean, the acceleration is in this direction. So pseudo force is acting in this direction. It means the, if you consider this is the point, the pressure is increasing in this way. So if you consider this H point, the pressure is increasing in this way. The pressure is increasing in this way. The pressure is increasing in this way. So this is the point of the minimum pressure. Minimum pressure. Increasing, increasing, increasing. And this is the point B. Increasing, increasing, and increasing. Right. If you consider this is the point, the maximum pressure will be over there. Is it clear or not? Copy this. So in this question, a steel tank containing density liquid of density rho move with horizontal acceleration A. The difference in the pressure. Suppose this is the tank, right, and the acceleration is A. The point at A and C. Is it clear? What is the length? What is the difference between the length A? If the acceleration is A in this side and you are sitting over here, so if acceleration in this direction, the pseudo force will be in this direction. So the force is acting in this direction. So can you tell me which pressure is more, C or A? Yes, C pressure is greater than the A pressure. By what amount? Say H rho G. The H mean the distance L. The rho is the density in place of density G. In place of G, the acceleration A will come. Is it clear or not? Now if you move from C to, this is C, this is the B, the height is what? Say H. So we go down, right? So the pressure will increase. If you consider the point B and point C, which pressure is more, B or C? The pressure of B is greater than C. By what amount? Say H rho G. Because G is the acceleration due to gravity downward. Right, in the horizontal direction, I told if it is accelerating in this direction, the pressure is increasing in this way. This is the equation 1, equation 2, right? So if you add them, 1 plus 2, PB minus PC is equal to what? H rho G plus rho L into A. So which option is the correct option? So the D option is the correct option. Is it clear? Now I assume this is to be the method 1. By method 2, how to solve? The pressure equation I can write from A to C, C to B. How? PA. If you are moving in this direction, pressure is increasing by what amount? L rho A. If then moving in this direction, pressure is again increasing, H rho G equal to B. So the L rho A plus H rho G is equal to what? PB minus PA. So what is the PB? This point is what? Wait for 1 minute. This is the PB minus PA, right? So the PB minus PA is equal to H rho G plus L rho into A. So this is the pressure difference, and you can write this is the method 2. The pressure difference between A and B is this, and the option is D option is the correct option, right? Copy this.